Good afternoon. My name is Ihab Ramlawi. I'm the co-founder and the managing director of DoPod. It's an honor to address all of you, and I'm very, very happy. You guys are the best in the region, the best in the market in the construction industry, and I would like to thank Autodesk for giving us the chance to share our experience. It is very, very important to share experience between companies. This is very important in our industry because we learn from each other. And it is very, very important that we build on experiences of others. So thank you very much. I start with a statement about Industry 4.0. Now, manufacturing have gone beyond that. They're talking about Industry 5.0. They have mastered mass production, electric cars, and today they are talking about autonomous movement and cars, while we are still stuck at a formula that is very hard to crack, how we can address mass production. And this is the whole core purpose about our presentation. From the beginning, we wanted to see a way to crack this by introducing industrialized construction in our way of working, in our processes, and like my colleagues said today, depending on a vision, people, and a process. Now, DoPod today is a modular manufacturing solution. The journey came from 2019 when we have decided to set up a company that works with the whole supply chain and complements a role of another company that we have in the group that we call DoBox. And DoBox today is one of the largest modular solutions in the region. DoPod provides parts of buildings, and by that we work on complementing roles of contractors, consultants, and developers, and most of the work that we do is in the most problematic area in a building, and that is the bathrooms. Why? Because it's such an intensive area with MEP and services, and it requires a high level of coordination. Now, the journey started as basically there is a lot of problem in offsite manufacturing. You open LinkedIn every day and you find out that this company is closing, this company is having a problem, distressed. And then when we studied the market, we found out there are a lot of issues in these companies, and that is none of these companies have started to talk about mass production, except that, well, basically we're gonna offsite work and put it in a factory environment. By doing this, we are not actually studying the issues that comes along with this. You are today working in a factory, then you need to operate as a manufacturing company, you need to talk about supply chain, you have a high level of inventory, you need to address the supply chain, and most importantly, how the information is going end to end in your organization. Are you able to collect proper data prior to saying that I am going to implement AI or automation in the factory? I recall a story when I was reading a book about Tesla, and one of the things that actually caught my attention, when they were struggling to take on the capacity of the company from 3,000 cars, at that time the company was actually in a distressed mode, and they had to take it up to 10,000. And Elon Musk was in a puzzle, and he was trying and trying and trying. And one of the things that he actually did is he went and walked on the factory, and at that level, he was fully automated. Then he was starting to look at how much time the robot is taking at every stage of the process, and he found out that it's inefficient. And at the end of the day, I have invested all of this money, but I actually invested it prior to understanding my business and the requirement of my business. And to do so, you need to have the right data, the right processes in place, and collect proper data, and have something what we call end-to-end integration. And the vision in DoPod have evolved, and today we look at self as a platform, not a factory. This is how we think about ourselves. The vision has grown to a level that we want to play a role to be an enabler to the industry more than actually executing pods day in, day out. Now, this is the roadmap of the industry. And like you see here, we have the conventional construction, off-site fabrication, where actually most of off-site manufacturers are. Then you see the basic manufacturing, advanced manufacturing, autonomous manufacturing, and site robots. We're still stuck here. And we are stuck here because we did not implement the manufacturing thinking. We did not implement how you are actually working as a manufacturers, and we are still stuck in a contractor environment. This is what is today slowing the advancement of this industry. And this is one of the things that basically we are trying to solve and introduce the efficient industrialized construction, because industrialized construction means that you think, design, operate as a manufacturer. And that is very, very important for you to master what you call industrialized construction. The thinking of industrialized construction took us to another level where we are actually talking about design for manufacturing assembly. I heard that term so many times. You know, I'm a civil engineer. My background is a civil engineer. And basically, I've spent the most time of my life as a contractor. And I know how inefficient the industry it is and how fragmented the data can be and how is it hard to implement construction technology when it comes to construction in general. And when we have thought about it, basically now we are working in a manufacturing environment. We have basically a benchmark from the best, and these are the pharmaceuticals, the manufacturing, who have actually mastered it. So let's look at a way how we can enhance our efficiency and think about assembly and not construction. We need to think about simplification of, how to simplify assembly, how to make sure that basically data is very clear, very easy, very simple to be able to scale up our mass production. And that is, in a nutshell, what design for manufacturing assembly is all about. The target is scalable, repeatable, and produce design for manufacturing assembly for faster completion, accurate costing, and this is a way that we found that it will enable us to capture proper data in our industry. Now we call this DoPod OS, and that's the engine of DoPod's vision. DoPod's vision was founded on three main factors or pillars. We said we want to be the best in design when it comes to the region. It's going to be expensive, but to be able to provide solutions to our clients, we need to invest heavily in design, which means BIM from day one, Revit, and take it to the highest level of development, because this is the only way that we can actually deliver value to our clients. Number two, we are going to invest heavily in digital integration and digital technology and find a way to work with the best in the construction technology providers and find a way to take these values and enhance our productivity in the future. And the third one is basically recruit the best in the region who will enable us to implement this. And that was a very challenging scenario, because at the end of the day, when you are thinking about manufacturing, industrialized construction, you don't think about civil engineers and architects. You think about industrial engineers, digital integration, and these are the chosen ones in the market, hard to attract in a construction environment, and what I call them actually the divas when it comes to the industry. Because, when you talk to an industrial engineer and try to convince him to come to the company, that actually operates as a construction company would say, okay, I'm wasting my career working with a company that is still in the old ages, and today manufacturing is talking about production, automation, and autonomous manufacturing. And that was very, very hard for us to pitch. On the other hand, when we started to talk about the end-to-end integration, we decided to work with our partners, the best in the region. So we chose definitely Autodesk on the design side. And then we said, to master digital twin, we need to find a way to take this information that we are actually building in the model and utilize it for more than presentation and collaboration. This data is valuable. We need to speak to an engine that is processing this data in a manufacturing environment. This data is going to form our process. This data is going to form our bill of materials, our inventory, and how we are actually managing the factory. So this is how we have thought about our data progression. We start with BIM, and we end up with ERP, and by this, we're able to identify, measure, analyze, improve, and control our process in the factory. Integration of BIM and ERP is actually what's driving today our ability to enhance, provide real-time data, and I'm going to share some information that we just started to get out of this process. So this is where the story begins and what we call as a data progression. I'm going to talk about how we are taking the process from the beginning and why we are doing every part of that process. Definitely, we came up to this after many trials, many processes, trial and errors, and that was really expensive. So as you see, like every project, you have a BIM execution plan, you have BIM team setup, configuration, BIM template. But when it comes to execution, we decided even if the requirement of the project does not require the highest level of development, we are going to go for the highest level of development. Because that was the only way for us to load enough data in the model that actually can be translated into material code, component structure, and cost, which will form the item structure and the work definition in our ERP system. So basically, that is the real definition. When you talk digital twin, this model is loaded by geometry and non-geometry information. And that information is very valuable. If you are not using this information the efficient way, then there is no process of the digital twin. You're not actually making use of the data that you're having. And this is how we have started to do it. And by this, we started actually to address every process in the model, the sequence in the model, and how we can actually translate the data from start to end until the delivery and the installation at site. Now, Autodesk is the foundation that enables DoPod to transform construction into a scalable manufacturing process. I swear, I wasn't paid to say this. Autodesk is not only supporting the workflow, Autodesk, as you see, is the workflow. And we need help from Autodesk as much as we can to learn about the continuous development that they are doing, because we believe there's a lot to be improved, and by working with our partner, we can actually excel the development and get to a better stage. Like I said, the story begins in a highest level of development, and when we are developing our models are loaded with data. This data is very, very important, not only to be coordinated, not for the facility management requirement, but this data is going to form what exactly is going to be translated into our work orders in the factory, which will be loaded with our resources, our bill of materials, which will be actually forming our inventory in the future. Now, I like to give this sample. There was a lot of complaints from my manufacturing team, and you can imagine such a simple system, a very, very small component coming with all of these parts. But that was the only way I can actually translate this into data. There is no point to say that you're able to extract your bill of materials directly from the model if you don't go to that level of details. And this is becoming our item master. This is what we actually control. This language is the same language we use in the manufacturing process and the same language we use in our inventory. It's all homogeneous. It's all talking to each other. That is the only way that we crack the code. This is how we started talking to the process, by actually loading the right data and speaking the right language that actually manufacturing can understand. The next step was basically DFMA, and there is a funny story about this. So I was actually in a trip to Toronto because I wanted to help my daughter to, getting to university. We're buying the furniture, so I made an order like everyone from IKEA, and basically it was very fast. It came in 2 days, and I came to the apartment. I found so many cartons, and I was like, "What's this?" And they basically, "Sir, we don't install." What do you mean you don't install? In our region, everyone installs. Sir, it's very assembly. It's very simple. It's an assembly process. Everyone does it. Okay. If you don't want, there are people who can do it for you. And they gave me a bunch of names, and then basically I called them. And the whole furniture cost was about $600, and they asked for $600 to assemble it in 4 hours. So like everyone, okay, I had plenty of time. I went downstairs. I went to Dollarama. I bought a bunch of tools, and that was about $20. And then I went up. I spent 2 days, but I did it. There was a clear map that basically I followed to come up with something like this. And that brought in an idea. When I came back to Dubai in a trip of 18 hours, I said, why don't we do that in our process? Why don't we take that pod to this process? If I am able to do this, like me, who are, the first time who does an assembly process, that will enable me to scale construction. I don't need people who are carpenters, people who knows how to do carpentry to do this. They just need to follow a map. A map that is very clear, with clear directions, with numbers. You do this, then you do this, and you do that. And if you end up with additional tools, you have to take it apart because it means that you have done something wrong. I went back to my team and I said, guys, I want the IKEA of the world in our industry. That's the only way we can scale up our business. This is the only way we can take it further. And this is what we have done. I went and I spoke to them. Thanks God, I have a very, very smart team. And basically, they came up with this process. And that is basically, if you look at this, this is a flooring layout with tiles. These tiles are going to be cut through CNC machines with a barcode. And that barcode defines that piece with the number itself. It's shipped, organized according to pod and type. When it comes for assembly, that guy who's installing the pod, he's not thinking. He's just following a map and a number. Now imagine if you can compare this to conventional construction, how much time you're saving, how much money you're saving because you're not getting and paying for additional skill. This is actually what defines DFMA. DFMA is about simplicity, is about designing for simplicity. And that is one of the key factors for the success of IKEA. Then the guys are very, very smart. They came back and said, listen, if we're able to do this, we can do better. And I said, how? They said, okay, we can introduce nesting. In Inventor, there is a solution where you can take all of these components, mix it apart, and actually reduce the waste in a building. Now, in construction, when we are addressing components like tiles or any item that you are going to cut and install at site, we usually have an assumed wastage, and that is defined by the industry. It's 15%, 20%, or whatever. And the thing is, basically, no one knows how much waste. Sometimes it's more, sometimes it's less, but that's always built into your price. And at the end of the day, that is not enabling you to add any value in the project. Now, think about this. If I come in, introduce nesting to your project, the project is large. If you are at a project and someone is working the tiling in the first floor and another is installing tiles in the 10th floor, same room exactly, these people are not speaking to each other. These people, what they are doing exactly is that everyone is doing his own work. If he needs a tile, he will go and get it from downstairs. If there is a cut piece at the corner, he will go down and cut it, and then he will have a piece over there, throw it behind his back, and that's his waste, without thinking that this part could be actually used in the other room. Why? Because he doesn't care about that. He's not speaking to that guy. He's not seeing what this guy is doing. He has a mission to do what he needs to do, and what he needs to do is install tiles at the site. Now, if you have taken this and you have studied it right from the beginning, does the cutting on, if you did the cutting on a CNC machine, every tile comes with a barcode. And I'm not talking about factories. That can also be implemented in our construction sites. And this is something that is going to come up as we move forward. Now, I'm going to go through this because this is faster, and I think I'm running out of time. So this is one of the aspects that we actually started to develop when we started to think manufacturing. Our drawings are to the highest level of details. If you look at our shop drawings, it is loaded with information. Some people prefer it this way, some people not, but this is the only way you can speak to manufacturing. If you are not having this level of information in your drawings, then you are not talking assembly. You need to talk assembly. You need to form a way of communication with your manufacturing, and that's the only way you can take it further. Again, our models are loaded with the highest level of developments, and basically, this is the only way we can actually take it to an accurate, measured way of progressing the factory. All drawings are detailed and structured into assembly work pack. Consistent coding ensures accurate picking is done at the factory. This is where it starts to get interesting. This is where we took all of this information and started to feed it into our ERP system. And our ERP system is the best when it comes to the region to understand manufacturing language, yet you need data, you need process, you need to communicate. If I am operating a manufacturing model without giving it the right direction, the right sequence, the right information, then it's useless. All the data that we have worked on previously translates into bill of material and work orders in the factory with proper sequencing, and this is what actually controls our efficiency. These work orders are loaded with information, loaded with resources. We are able to increase our efficiency as we move forward. And now all of this process, and I call it the power of data, results the following. These are only samples that we started to get out of the model. I started the discussion by saying we just implemented this, and we're only getting to know how much power we are getting out of the system, and it's plenty. And by doing this, by the way, we have implemented a very, very efficient way, an integrated Power BI, to take all of the information that we have in the ERP to give us a way that we can control our processes a way that we can control our efficiency, like inventory aging, how much we have inventory in our store, is it too much? Are we able to take some of the inventory out? This is very efficient in controlling our cash flow. Another way is our evaluation and country inventory valuation, and that is one measure that only financial institutions know, because it shows how much you are able to control your cash flow. This is one very important thing, and that's first time through. This shows us which pod came into the factory, got out without any problems, without any inspection problems, without any quality problems. The pod came in, passed through all of these stages without any problems. This is always a way that shows us where are we having a problem, and when you know where you have a problem, you're able to address it either from the design side or maybe the team that is installing it that side. Another way of doing it is this is a whole study of pods quality analysis at the stages that we have. You're only able to do this because you have work orders. If you don't have this, you don't have data, you're not able to do this, and you're not able to find out how efficient you are. And when we say industrialized construction is the only way that you can increase efficiency, this is the only way you can do that. Now imagine you take this to a second level of innovation. Now you have this data. This data is going to be your power. You are able to integrate AI. You are able to evaluate if actually automation will help you or not. And by this, I end my presentation. I think I have exceeded my time, so thank you very much, and thank you for allowing me actually to present to that.